Hello, Algebra 2 students, and welcome back to Chapter 3. Last time we did 3.2 and 3.3, which was solving systems of linear equations using substitution and elimination. Today we are going to use the same type of strategies, except we are going to jump into 3x3 systems. 3x3 systems. Now, what makes a system 3x3? Well, before we've been dealing with 2x2 systems. Well, the first two is we have two variables, typically x and y. And then the other two that we got in here, well, I have two variables and then I have two equations. Thus, I have a 2x2 system. When we do a 3x3, we will have three variables and three equations. There are some different possibilities in a 3x3 system. One possibility that we could have is we could have exactly one solution. Now here's kind of the tough part to visualize. Is a 3x3 system actually is talking about 3 sheets of paper. And 3 sheets of paper can intersect at a single point. A really great looking picture is this one over here. You can really see the 3 different colors of paper. And the single black solution right here. Okay? That's a single point. Okay? That is the point that we are going to be searching for. Now, in this, we will always have ordered triplets, x, y, and z now. Okay? Now, there is a chance that the planes intersect at a line or are on the same plane. This can happen. I think a great representation of it. I really like this first one right here. When we look at it, we can kind of see the different colored planes and how they intersect at this line right down the middle here. That color really doesn't show up. Maybe I'll try it green. This one right here down the middle. Okay, this line right here is where they all hit. Now, there are infinitely many points on that line, so there are infinitely many solutions. And then we have the last situation, which, like we had with the lines in a 2x2 system, there is no solution. This happens when there are parallel planes or when there's no common solution. There's no common intersection here in this box green. Okay? You do not need to try to copy down this part for your notes. You don't need to try to copy this specifically down. Instead, okay, you just need to understand that these are the 3 types of situations we can have. So, kind of what I've got it for. Been working with 2x2. Now we're going to work with some 3x3. Okay, a big thing, kind of what I hinted at a few slides ago, is we will have this idea of x, y, and z. That is known as an ordered triplet. Okay. And here, there's going to be a lot of work, sure. But the big thing is we need to really be organized. Okay, we got to be organized here. So let's start with just kind of a simple one here. It says determine if the ordered triple is a solution to the system. If I were trying to figure out if this were a solution, if it was a solution, I should say, then this point right here should satisfy all 3 of the equations. All 3 of them. Well, I know that this is an x, y, and a z. Well, I just need to take those and I need to plug them into each one. I'll do this one over here in red. I'll take 4 times this 3 for my x minus a -2 plus 2 times 1, and that should equal 16. Now I just need to simplify. Well, I know 4 times 3 is 12, minus a negative is plus 2, then I have plus 2. Well, does 12 plus 2 plus 2, well, I think that's 16. Does 16 equal 16? Yes. That only checks out for the first one. Now I have to check the next one, which I'll do here in blue. That's negative 3 times 3 plus 2 times a negative 2 minus 4 times 1, and that should equal negative 17. Again, multiply here, I get negative 9, minus 4 here, minus 4. That should equal negative 17. I think negative 9, that makes negative 8. Okay, so I think that's negative 17 grade. That's exactly what I should have. This second equation checks out. Finally, I get to check the last one, which I will do in green. Same type of thing here. I have negative 3 times, oh, I'm sorry, it's not negative 3. I have, oh, it's just x, so that's 3 minus a negative 2 minus 3 times 1 should equal 2. That's 3 plus 2 minus 3 equals 2. I think that's going to be a 2. Oh, 2 equals 2? Yes, it does. Because they all work. All work. Thus, my ordered pair, which was 3, negative 2, 1, is a solution. That one's not too bad, just plug it in. Now, if just one of those equations didn't work out, then I'd have to say it's not a solution. Here's a great one to try out on your own. I would pause the video right now, write this down, and check this one for yourself. Okay, check this one for yourself. Okay, so now that you tried it out for yourself, you can see that my work's already up there. I tested this very first equation right here, and it ended up not being true. Oh, well, if it's not true, I don't even need to bother with these next two, because it doesn't matter. One of them didn't work. Thus, this point is not a solution. All right, let's move on here. Next, we got the steps for a 3x3 system. What I'm going to do is I am just going to run through these. You should be pausing the video here as we go, writing down each step sequentially. First, okay, we have step 1, which is rewrite the linear system in 2 variables using the elimination method. So I need to eliminate one variable. Doesn't matter which one, but I got to get rid of one. Then I will solve the new system for both of the variables. Old methods, which is 3.2 and 3.3 from last class. After that, you will have 2/3 the answer. Then you simply need to substitute in the 2 answers you have and solve for the last one. Okay? This is a great time to pause the video, make sure you're getting these things down. You need these steps in your notes. Okay? Make sure these are in your notes, and then come with me to the next example. All right, so we got 2 problems to get through on your video problem worksheet. This is the very first one. Okay, the very first one on the worksheet. On the worksheet. What I like to do is I actually like to write A, B, and C here. Okay, A, B, and C. I like to name them. Next thing I want to do is I want to do step 1, which is eliminate one variable. So I'm looking at the equations and I'm trying to decide which one's going to be easy to get rid of. I see that the x's, this 2x and this 2x match. That those match. Well, if they match, that should make it rather easy actually to get rid of them. The only other one that I have to mess with is this other x up here. I need those all to be 2's. Okay? All to be 2's. So, if I'm going to do that, do I have to do anything to b? Well, no, because it's already a 2. Do I have to do anything to c? Well, no, because that's already a 2. All I have to do is I have to take 2 then times my a equation. Okay? And now I need to pick another equation to work with. I will take 2 times a minus my b equation. This is really key. You can see me writing a plan. I'm taking 2 times a minus my b equation. The next thing, that will give me one equation. That'll give me one equation. I need another one. I think for my other one, and I'm going to need this to be a negative 2a. I think for my other one, I'll take negative 2 times my a equation, and then, oh, I'm sorry here. I don't need this to be a negative. I should be fine. I should be fine with just those being positive. So I have 2a minus b for my first one, and then I have 2a minus c. Okay, well, let's see what this looks like. If I get 2a, so I'm taking 2 times my a equation, which is, right up here I have my a equation. I'll take the whole thing times 2. So when I bring this in, that gives me 2x. That gives me plus 4y plus 2z equals 20. Now b, I have this negative sign that I put. So when I do this, I'm actually just going to multiply through by this negative 1 here. So I'm going to take b times a negative 1. Well, that should be rather easy. That's just going to make everything negative. We're opposite signs. So that's a negative 2x, a positive y, and a negative 3z. That equals a positive 5. There's my first equation set up. Now I'm going to work on my 2a minus c. Well, I know from before that 2a is just 2x plus 4y plus 2z equals 20. I know that now I'm going to push this negative 1 through c. So it's like I'm taking c times a negative 1. That'll create negative 2x plus 3y plus 5z equals negative 27. Whew. Now this is a lot of work to set up. Feel free to pause the video. Make sure that you're getting enough time to write down the questions or the steps one at a time here. Next, if I've done this correctly, I should be able to add these two equations. Okay, I should be able to add and eliminate a variable. As I add, these two x's cancel. Leaves me with 5y minus c equals 25. These will cancel again. I have 7y plus 7z equals negative 7. If this is right, you are good if you have two equations, both with the same variables. In this case, I have y and c in both. So I'm good. I'm good there. All right. Now I move on to step 2, technically. Step 2, solve the 2x2 system. When I look up there, I mean, I already have the 2x2 system. All I have to do now is I have to solve this thing. 5y minus z equals 25. 7y plus 7z equals negative 7. This is exactly the type of problem that we did back in 3.2 and 3.3. You can solve it any method. I think it makes sense to multiply this one by 7. That would make it 35y minus 7z equals, if I have 7 quarters, I think that would be what, $1.75? Then I'm ready to take these two equations right here and add them. So that gives me 42y, these cancel, equals, that's 168. Now would be a great time to, look at this. Oh, you see 42, divide by 42. Now I just have to figure out how many times 42 goes into 68, and if it's a nice number. Let's see here, if I use my logic skills here, I guess it's close to 50. 50 would go into 150 3 times, so we could try 3. That would be 126. Okay, well that's not quite enough. What if I added one more 42 in it? That'd be 168. Oh, this is what I want. So I have 3 42s and one more. So 168 divided by 42 must be 4. Okay, it must be 4. Here's a big key. I know that y equals 4. This is important. Maybe I'll highlight it here so I don't lose it. Now I need to find out what x is and z. Well, if I know that, I didn't want it to be quite that big. Maybe I'll undo that. But that's okay. I can use that purple there. Now, if I know that y is 4, I wonder if I can't take that 4 right there and plug it in right here. So that would be 7 times 4 plus 7z equals negative 7. That's 28 plus 7z equals negative 7. 7z, subtract the 28, and I would get negative 35. Divide by 7, and I get z equals negative 5. Okay, well, I got another one. I got another solution. Okay, that seems important. Maybe I'll highlight that so I don't lose it. I got 2/3 the answer. The last thing I got to do is I got to take those two answers, 4 for y and negative 5 for z, and I need to plug it in all the way back up here into one of these equations. One of these 3. It doesn't matter which one. I think I'll take the first one though, just because it looks rather easy. So I have y equals 4, remember, and z equals, was it a negative 5? Let's double check. I don't want to plug it in wrong here. Go all the way down here to the bottom. Yep, looks like a negative 5. So I have x plus, or did something a little goofy there. I have x plus 2 times a 4 plus a negative 5 equals 10. Well, let's just do some math. That'd be x plus 8 minus 5 equals 10. That's x plus 3 equals 10. Subtract, and I get x equals 7. Now here's the key. We did all this work. What do I want my answer to look like? Well, I wanted it to look like an ordered pair. Well, that's x, y, but it's not a pair anymore, it's a triple. So it's got a z. Okay, well, x is 7, y is 4, and z is negative 5. And there is my solution. Now is an absolute great time to check that by plugging it back in. Make sure that you have this entire problem done, okay? And you understand it completely before you move on to the next one. All right, Algebra 2 students, this is our last one. We're pushing 20 minutes on this video.